Hello, everyone. I'm really happy to have you all in today's webinar. And my name is Tim Schneider. I'm the head of customer value here at Binomics. And I previously worked with CPG companies at BCG. And I will be mainly moderating the meeting today and answering any questions that you might have in today's chat or that you might have afterwards via email. And happy to follow up, of course, anything also via email directly with me. And I'm here together with our founder, Dr. Ingo Reinhardt, who will be leading the webinar today. So he has more than 13 years of experience in pricing and has developed basically our Binomics method, so the core of our application, and is the author of several white papers around pricing and its evolution, and a very strong topic expert. But before diving into our webinar, a quick intro maybe to Binomics. So Binomics at its core is a revenue management and pricing solution, which is developed to provide you with an holistic optimization and analysis approach with higher predictive accuracy and increased speed to insight. And in turn, or basically by that, should provide you with better profitability. If you have any questions around the Binomics tool, please feel free to contact me via email or to again write your questions down in the chat in the Q&A. And now, with no further ado, I would hand over to you, Ingo.
Perfect. Thank you, Tim, for the introduction. I hope it was others to be a bit quiet still, but I hope others could hear. If you have any questions, not just on our tool, but also on the content of the webinar, just write it into the comments, and we'll try to answer everything towards the end of this webinar. So what's the topic today? So the topic today is want to talk a little bit on our perspective on pricing tools, a little bit on the different variations that there are, and also in the context of the history as we move from different technologies. And at the current time, this means, I think, for most of us, at least that's our impression as we speak with different companies, that Excel solutions are still very widespread, and many are considering moving to SaaS. And we want to talk just a little bit on what that means, what the advantages, disadvantages are, and the implications. This will be the topic of this webinar today. Of course, we'll do that a little bit in the context of our own solution, because that's the one that we know best, but we want to just talk broadly about the topic. All right, so to get started, let's start with a say famous example in pricing that maybe some of you already know, also on the dangers of working with pricing solutions. And it's a famous example in pricing, but on a not so famous book. It's a biology book, Making of a Fly, that was listed on Amazon. And on Amazon, if you post, or if you're selling your product, you can have an automated pricing strategy that reacts to also what your competitors do, different things. And in this case, there's this biology book, The Making of a Fly, and there were two bookstores that offered the book, and they had each a pricing strategy. The pricing strategy of the one supplier was, okay, I always want to be a couple of percent above the cheapest in the market. And the other one had the pricing strategy that he wanted to be 0.17% below the most expensive supplier. And if you put these two strategies together, one always steps a bit larger step above the other, and the other then follows just below it. And you can see that this logic leads to an ongoing price increase. And what happened, because it's a product that people don't look at very often, this went on, and at some point the pricing went up to $24 million, and it even made headline news. I think this is the New York Times or Fast Company where that brought the story. So this is just, I think, an interesting example of what can happen with pricing algorithms when you leave them do their thing unchecked. There are many other examples like this. Maybe other famous examples include Uber's surge pricing, when in a case where there was, I think, a terrorist attack in a city, in a certain district, And because of that, demand for rides increased massively, and the algorithm didn't have a natural a ceiling. Prices went up massively, a couple of $1,000s for a ride, and this of course produced some backlash for the company. So there are many examples like this where you have a pricing algorithm and it works on its own unchecked, where it produces results that are very much not intended. And this, I think, is an important reminder as we go into the topic that it's really difficult to have set up an algorithm that considers all corner cases and always does the right thing. And that's why, of course, we as pricing professionals to work in this environment. This is just to get started. So, and maybe let's take a few steps back in the history of pricing, because pricing, I mean, it's essentially as old as money. So as for most of the time that we had civilizations and we had goods to sell, we had money and prices. People had to decide what the right methods are to set these prices. And of course, you start with slide ruler, calculator, but I think for us, most of us, the most relevant tools that are used in pricing are pretty much from the 80s, different Excel solutions where you implement different pricing methods, as well as I think we're seeing the shift or the growing importance of SaaS solutions coming in the 2010s and much more strongly now in the 20s. I think this is really going to be the decade of pricing SaaS solutions as they become more and more relevant. At least that's the impression we get from all the people that we speak to. Just generally, as we talk about these pricing tools, I don't think there's a single category of pricing tools, but there are different areas where these pricing tools operate. And from our perspective, there are three main areas where pricing tools are being used. The first one is essentially to collect and assess market data. Here you have everything from collecting and interpreting sales data. So for example, sell in, sell out data, depending on your industry, transaction data, competitor insights, customer insights, all the market research you do. It comes in different forms in different industries. It comes in forms of essentially tables, Excel tables, or it comes in the form of presentations when you run market studies. So all of these different information, and there are tools in place that help you make sense of these. For example, if you have demand across different channels, or you have insights on how different price points lead to different sales amounts, you can deduct something like price elasticity, you can deduct something like willingness to pay of customers, make all kinds of inferences from the data that you collect to then be able to use that for your pricing decisions, which brings us to the second key area where tools operate. And this is essentially the optimization of prices and products. And for that, we have as pricing professionals, different methods at hand. I think the most relevant are something like a price elasticity based pricing, where you use the price elasticity. That means an understanding of how demand reacts to price changes to set your proper prices. And in the simplest case, you can apply rules like in the profit optimal price, you always have margins times price elasticity is -1. So for example, if your price elasticity is -2, then the profit optimal margin is 50%. So there are these rules, and they can, of course, be also used by pricing tools. Other pricing methods include, for example, competitor pricing, which we see quite a lot. Also very naturally, if you are not so sure what your pricing should be, you look at what your competitors do, and depending on how strong you feel compared to your competitor, you put a markup on your competitor's price, or the average of all of your competitors, or essentially the market price, if you want to call it that. You put a markup, maybe 5 or 10%, or if you're more defensive, you might say, okay, let's mark down from this competitor price 5 or 10%, and this gives you the price that you want to have. Also, we see a lot of cost plus pricing, where essentially you work with the understanding of your cost for your pricing, and then put on a markup on your cost, Also things like value pricing, where, as you see here on the right side, for example, you have the ski jacket, and there are different variations of the ski jacket. There's a down filling or synthetic filling, and it's more or less water resistant. And based on these value drivers and different attributes here, you define the different pricings for your different jacket variations. So there are all of these different methods in pricing, and then typically, I think we'll look at an example on the next slide. They produce different results, and then you have to come up with some sort of combination or aggregation of the different methods to find your best price. And I think the last method that's relevant is the last area that's relevant is what we typically call price management software. And this is relevant if you have to manage a larger portfolio of different products. So for example, if you're a retailer, if you're maybe at the very large end, you're on Amazon, or you're operating a smaller store, you will always have the challenge that you need to manage your prices. For example, if your costs increase, you need to be able to pass on this cost increase if this is what you want to do. Or if you want to implement a price increase, you need to be able to manage something like a +5% price change on all of your products. Or you want to say, okay, let's increase 5% on all my blue products, whereas I might want to do a 7% price increase on my red product, so that you have some sort of a differentiated price increase. And you need to have tools in place to be able to do that. And this is the class of price management tools. What we want to talk, I think, in this webinar mostly about is the category here in the beginning, the first two. So how do we interpret data, and then how we use that to set different prices. And as I said before, we did a survey, I think last year, where we asked pricing professionals what methods they used. And we see that in the field Excel, and this is not only my impression from last year, but also the impression that we're getting in the current year. You see Tim nodding as well, that most of pricing professionals are still doing a large chunk of their work in Excel. So the use of tools is still very limited for most of these pricing challenges. So this is what most do, and if you do that in pricing, you have these different challenges. There are, and this is just a simple example of how this typically looks like, interested in if you're doing it differently with your pricing. But this is just a bit simplified, but this is in principle how these pricing models are run if they're done in Excel. So we have, here in this example, we have our 4 different product variations. So On Peanuts, that's our brand, and we sell our products in different sizes here. So 1,000 grams down to 250 grams, and there are 2 competitors, A and B, who also sell different nuts in different sizes. And we have our costs, and using, for example, a regression analysis, we came to the conclusion here in this example that the price elasticity for our products is -2. So this is what we figured out. And if we then do an elasticity-based pricing, we have initially the current situation before we make the price change. So with the old price, we have these prices. We sell at $16.99. We sell 2,655 units, compute the revenue, the profit, everything here. And if we do elasticity-based price optimization, then as said before, the rule that optimizes the pricing is price elasticity here, the -2 times margin needs to be -1. And this is the case if we sell this product here at 18 euros, the second one a bit cheaper at 12, and the next one at 9, and the last one at 5 euros. And this would give us these outcomes. And as you can see, the profit goes from, in this model, from 44.7 thousand euros to 46.2 thousand euros. Revenue in this case also increases a little bit. The units also increase. This is not always the case, but in this portfolio, it is the case that we have an increase in units, in revenue, and in profit, which largely comes from the fact that we massively increase the sale here of the larger the smallest pack. If we did something like value pricing, maybe based on workshops, we still see these a lot, where customers essentially go through these different value drivers, the brand and the size in this case, and define how strong their brand is, for example. So here in this case, there is the company thinks that their brand is more valuable than the brand of the others. So they have a brand markup of €5, and they have for their own brand, and their brand markups of €3 and €2 for their competitors. They have a size-based markup, so €5 for the largest one, 3 for the middle one, and so on. So these are typically how these value-based pricing models are set up. You split up your products into the different value drivers, and then assign different values to the different attribute levels, and use this to compute the price. In this case, the price for the large pack is 16, for the next one is 14, and so on. So you get different price levels here. And what we still see surprisingly often in these models is that you get from the elasticity-based pricing different results than from the value-based pricing. So here we have 18 versus 16. And then typically these are, and I hope this surprises some of you, they're just averaged out. And then maybe in this case here, they still apply the price threshold in the end. So what happens in the end is that they stay the $16.99 for the first product. They stay with the price for the second, but they change the price of the two smaller packs. So this is typically what we see, and this is what you can do, at least for smaller portfolios within an Excel model. And what I want to show is what the advantages of a SaaS solution are in this case, because this one here is based on a real example. It's anonymized, so in reality it was not about nuts, but about something else. The volumes have been scaled, but the case is based on a real example. And I just want to show you what can be done in a SaaS solution. Tim, can you see my screen?
I can see your screen, yes.
Okay, perfect. So this is what this case here looks like in our solution. So you have these different products here, our 4 own products at different sizes, and you can, it's based on these value drivers. So you could, in theory, also change the product, the sizes of it. You can also input the cost that we had before. You can change here. You can, if you're selling through a retailer, you can put in the discounts you have. You can put in all the real pricing structure with list prices, shelf price, and so on. You can remap the reality here. And what you then do is you show this, and I don't want to go too much into the details about how the technology works, but essentially it's based on what we call the virtual shopper model. And the idea is that we create, based on observed data, a model of the shopper behavior, and we use it to create these virtual shoppers. And in the end, they behave just like real shoppers. So you can use this tool here to replicate the decisions of real people. So if you see, for example, here, if we change a price of a product, we increase it here by 1%, 20 cents about, we see that we lose a certain number of units, 6% of units. And this is what happens in reality, because we've managed to replicate the behavior of the real shoppers, to include them here in the model. And then this model behaves like the real customers. And I'll show you in a second that it actually then matches the real behavior. We don't want to talk about this in too much details. I think we have other webinars where we explain it in more detail, or if you're more interested, we're also, please reach out, happy to discuss this in detail. So what this does is, in the previous Excel model, typically what you can only do is that you have a price elasticity that only depends on this one product. So you've measured, you've done your regression analysis, and it gives you an elasticity of -2. And it really can't look left and right how it depends on other products. So, but what in reality happens is, you see here, if we, let's say, switch to the units, we lose 170 sales here, and some of them go to my other products, because if this is more expensive, then to some, the 750 becomes more attractive, and they move here, some move here, and some also move to the smaller pack. Some also move to a competitor, and there's these 5 who don't buy anything anymore, because the product has become more expensive. But if you then also increase the price of the nearest alternative here, then you see that the price elasticity goes from 5.5, minus 5.5 to minus 3.4. So it decreases because the alternative here has become also less attractive. So something like a price elasticity doesn't just depend on this one product, but also depends on what else is going on in the market. And if you increase even more of these prices, you see as the alternatives become less attractive, the price elasticity overall decreases even more. So you can really actually model the interdependencies between these prices. And this is something that I haven't really seen anyone figure out how to do in Excel at scale. So this is really, if you want to understand these effects, you really have to rely on a SaaS solution like this one, if you want to get this right. And just need to move this here. What you can also do, and then I'll look at the results, you can really look at like the demand functions for the different products. And if you change the price of one, you see how the other demand functions also move. So you really have this interdependency. And what you can also do in a case like this, and you can just look at the profit optimum here, and it gives you the optimal price for the different products in this case. So, and with this, what we see here is that in this optimum, we sell these 7,150 units, have an expected profit of roughly 48,000. And with this, if we go back to the presentation, Tim, can you see the presentation again?
Yes, I can see the presentation again.
What you see here is that in the Excel example here, this is what we did in the Excel. We simulated this case, and this is what the Excel model gave us. It gave us a units of 10,641. It gave us a product of 46. And what really happened, we A/B tested this here in this case, is that the actual units were about 20% lower, and the actual profit was about 25% lower than predicted. Whereas in the model case here, it was much closer to what really happened in reality. So it shows you that getting these interdependencies right and getting the market right is really an advantage to what you would get in an Excel model like this. So this is just to highlight a little bit of what essentially the future can bring as you using SaaS solutions become able to use much more detailed and precise models to model how customers react to a price change, also considering maybe different competitor reactions than what you can really do in an Excel model. So I think this is an interesting insight on what the future holds here for pricing tools. So just to summarize what we've discussed, as we move from what we showed here on the Excel model, what we showed is that it's really difficult in an Excel model to really reflect actual customer behavior, to understand how the whole portfolio reacts to price changes, also considering competition and other things. That's much easier with the larger computing power that we have in these Excel models. It really allows you to be much more dynamic than you would be in these more static Excel models. And also we haven't shown this here in more detail, is that you have the ability with these SaaS solutions to also integrate further data sources. So integrate really your your transaction or sellout data that you use to create these models. We've only touched lightly on this in this webinar now, but you can integrate really these solutions into your wider environment and really make it useful for these price decisions. If you're talking, we've discussed this here on the class of price management tools, these can of course be automated to the point where you have really price changes that are done automatically by these solutions, but always be careful with this, as we showed the example in the beginning with the making of a fly. If you just leave it to the algorithm, that's always a difficulty, or it can produce unexpected results. So be careful with this, but as we showed here in the example, and with the interface that we used here, if a human looks at it in the end, then these mistakes shouldn't happen. At least we haven't seen them. Tim, have we?
We haven't yet. We haven't yet. Thanks a lot, Ingo. I think very, very interesting content. And now looking at the time, coming directly to the questions. So please, everyone, feel free to use the Q&A button on the very bottom of your screen, so to ask any kinds of questions. And I would say, Ingo, we pick out a couple of them, and the rest we can answer in the follow-ups. I think coming to the first question, which data do you use for the Binomics model? So probably basically what's the data inputs?
Yeah, so just really in a nutshell, so it depends a bit on the industry. What we work with a lot is, for example, transaction data that show you really how many units you sold and who sold these different units in a specific week, for example, or sell in or sell out data that allow the model to really get a precise like a precise understanding of really what happens in the market. So for example, if you're selling through a retailer and you have the data on your own sales, your competitor sales, and the prices, maybe also some details on what products were in promotion or where they were located in the store. These are useful information. Happy to, if you're interested, just reach out to us. But we can work with, so as I said, with the sell-in, sell-out data, transaction data, but also we can include survey data like conjoint analyses as a combination, or also standalone when other data sources are not available. These are the data sources that the solution uses. So in general, all the information or all the data that's used in pricing. And I think one important advantage of the virtual shopper model that we have is that you can also very naturally integrate different data sources. So for example, if you have like a base model based on sellout data in a market, and you're thinking of introducing a new product that includes some new attributes that haven't been tested in the market yet, a new brand, for example, or a new design, something like that, you can really integrate these different data sources and use the really robust, based on actual sales data, build base model and integrate the new value drivers that come from a survey because they haven't been in the market yet. So there are lots of options. Happy to discuss your specific cases.
Thank you. Now coming to the next question. So how do you measure the interaction? Can you hear me? How do you measure the interaction of products?
Yeah. So in a nutshell, the model that I showed is attribute based. So all the products are made up of their attributes. So you have brand, different sizes. And just like if you're familiar with how the conjoint studies work, in a similar way, these virtual shoppers that we use in the model have preferences for different attributes levels, different combinations, and there are some dependencies between them. And then based on their specific preferences, each of these virtual shoppers makes a decision. And if you then increase, as we did in the example, increase the price of one product, you see that for some of them, another product becomes more attractive, and then that virtual shopper switches between the products, and this allows the model to determine the movements between different products. So what you have typically is that if you increase, let's say you have a market as we had here with, I don't know, 10 products, maybe you increase the price of one, then typically a lot of them will move to a different product in the market, and some will leave the market because the one product that they wanted to buy is now too expensive for them. So it really replicates the movements and the dynamics in the market, and this is something that we've tested across a large number of cases to know that this is really what's going on.
Thank you. Okay, so maybe looking at the time, last question. Is it possible to consider variations within channels regarding not only channel cost differences, but also different customer behaviors?
Between different customer behaviors between channels?
Yeah, so that's how I read it. So it's possible to consider variations within channels. So variations meaning like cost difference across channels and also different customer behaviors across channels.
Yeah. So typically the model is channel, or let's say if you're thinking like of your CPG company that sells through different retailers or channels, the model is set up channel or retailer customer specific. And with the information from that channel, it also captures differences in customer preferences or behaviors as far as they're reflected in the sales data, for example. So if you have, let's say you have two channels, and you have in the two channels, you're working with different, let's say simplified, you're working with the same price, but in one you have a much larger market share, then it seems that the customers in this channel have a higher, in this channel you have customers who with a higher preference for your product, so the value that customers give to your product is higher than in the other channel. And because it's set up on a channel or retailer specific level, the model captures these differences that you have between channels. So that is possible, and that's, I think, maybe you have more detailed insights on that. That's also the usual case, that there are these differences between channels.
Yeah, absolutely. I think having different buying behaviors across channels, that's like clear from the data, and also our model reflects those differences. Yeah. Okay. Looking at the time, I would say let's go over to the last slide. Thanks a lot, Ingo, for answering those questions and talking through the webinar. We have, of course, more webinars coming up. So next webinar will be in May, pricing and revenue management after inflation, and then after that, at the end of May, pricing and revenue management methods. So everybody, please stay tuned. I think both the upcoming webinars are going to be very interesting. And to stay tuned, basically follow us on LinkedIn, basically follow us on LinkedIn, and also reach out, check your emails for the next webinar information.
Perfect. Thanks. I think we're already a few minutes over time. So thanks everyone for staying on. Have a great weekend and hope to see you again in the next webinar. Bye-bye.
Bye-bye.